Let's look at some rational expressions that we're being asked to add. And you can see again there's a plus sign in between them, so definitely addition. And we have two polynomials for the denominators, but they're not the same because we don't have an equal sign. There's no equal sign there, so we have to have a common denominator before we can do anything with these rationals. So the first thing I want to do is look at the first denominator, and I'd like to factor it, so I'll use sum product method, and I have a sum of -9, that's from the middle term, and a product should be 2 times -5 or a -10. So I'm looking for two things that multiply to give me a -10, and I know I have 10 times 1, and they're 9 apart, and if I put the negative on the 10 when I add the two of those, I will get a -9. So my pair is -10 and 1, and I'll put them in instead of my middle term because I can't just go straight to my factor pairs because I have a 2 here for my lead coefficient, so I can't just take the shortcut. So I have to substitute in. I have 2x squared minus 10x plus x, or 1x for this one right here, and then minus 5. So I look at my first pair. I'm doing factor by grouping now, and I can pull out a 2x, and I have left x minus 5. And then this is already x minus 5. I don't want to change a thing, so I just think about multiplying by 1, which won't change anything. And then I can factor it to 2x plus 1 and x minus 5. So my factored form for this denominator, 2x plus 1, x minus 5. And now I want to look at my second denominator. I have a sum of -1 and a product of 6 times -2. There's my 6 on my lead coefficient and a -2 for the constant. Now this is another one that I can't use my shortcut on, and my 6 times -2 is -12, of course. And I'm thinking, what times what is 12 that is 1 apart? And I think 3 times 4, and I need to have a -12, so one of the two has to be negative, and it needs to come out to a -1. So if I put the negative on the 3, I will get a -12 when I multiply, but when I add those two, I get a +1. So I picked the wrong one, so I'll switch and make it a -4 and a +3. And when I add those two, I will get a -1, and I do still get a -12 when I multiply them. So 3 and -4 are my pair. And then because I have a 6 again, I will have to substitute in for my middle term. So I'll have 6x squared, and then I can do plus 3x for that +3 right here, and then a minus 4x for the -4 right here, and then minus 2. Now I'm doing factor by grouping. My first two, I can pull out a 3x, and I have left 2x plus 1. And for my last pair, I can pull out a -2, and I have left +2x plus 1. And then I see I have a 2x plus 1 on both, so I pull it out as my greatest common factor, and I have left a 3x minus 2 as my other factor. Now I should be able to find my least common denominator, and remember to do that. I take both of the factors or all the factors for my first denominator because I have to be able to represent each denominator in my common denominator. And then I look at my next denominator. I need a factor of 2x plus 1, and I've already got one, so I can share that one. And I need a factor of 3x minus 2, and I don't have that one, so I do have to put it on 3x minus 2. So now my common denominator represents, with the first two, it represents my first denominator, and with the first and the third, it represents my second denominator. Now I want to build up, so this is going to have a build up strategy because there's no equal sign. So I have to use the build-up strategy. So I have a 2x plus 1 and an x minus 5 on my first rational. I need to also have a 3x minus 2. So I will multiply by this first rational, this 3x minus 2. And I want to multiply it in the denominator. But to be able to do that, I have to have a form of 1. So I have to also multiply it in my numerator. And then for my second rational, I have the 2x plus 1 and the 3x minus 2, the first and the third, but I'm missing the x minus 5 from my common denominator. So I will multiply the second rational by the x minus 5, and remember it has to be a form of 1. I'm going to write that because it's very important. Multiply by a form of 1. And when I say a form of 1, we're talking about something that reduces to 1. So x minus 5 for the numerator and the denominator as well. There I've got a form of 1 here and a form of 1 here. Both of them have the same thing over itself. They reduce to 1. And when I multiply something by 1, I don't change its value. Just like when I was factoring over here and I wanted to leave it as an x minus 5, so I said, well, I can make it a 1 that I'm pulling out. It won't change the value at all. Same idea here, multiply by a form of 1, and I'm not changing the value of my rationals. And then I actually need to go ahead and use FOIL for this numerator here, and FOIL for this numerator here. I'm going to leave my denominators in the factored form that is that LCD. So for the first rational, I multiply using FOIL, so I have 3x minus 2, there we go, 3x minus 2 times the quantity 2x minus 1. So 3x times 2x gives me 6x squared minus 3x minus 4x and plus 2. All of that over the 2x plus 1, x minus 5, and the 3x minus 2. So I have all three factors in my denominator, and my numerator is mostly multiplied out. I can combine these two like terms in the middle, and I will get negative 7x. Then I have a plus sign in between. I'll carry that down. And I want to do the same thing with these two numerators, use FOIL to multiply them out. So I'll multiply x times x, gives me x squared, x times negative 5 gives me negative 5x, 3 times x, positive 3x, and then 3 times negative 5, a negative 15. Kind of separate my scratch work there a little bit. And then my denominator, I have a 2x plus 1. I have an x minus 5, and I have a 3x minus 2. So now I can see I changed the order a little bit, but when you multiply, order doesn't matter. And I have here the exact same two denominators. So I have like terms here in the middle, negative 5x and a positive 3x. That'll be negative 2x. So I can use the negative 7x and the negative 2x for the two middle terms on each. Now I want to combine like terms, so I have 6x squared plus x squared. I'll do 6x squared plus x squared. I'll put the like terms near one another. I have minus 7x, and on this one I have a minus 2x, and then I have a plus 2 and a minus 15. All over that common denominator. Now I have the same denominator for both, so I just write it one time when it's a single rational, x minus 5 and 3x minus 2. I end up with, combine my like terms, I have 7x squared minus 9x minus 13. And it's all over the 2x plus 1, x minus 5, and the 3x minus 2. Now the very last thing I need to think about is, can I reduce this one? Because if I can reduce it, then I should do that to write it to write my answer in the lowest terms possible.